So, what do we know? If something's a factor, when you divide, you're going to get a remainder of 0. So to find out if any of these are a factor, you need a remainder of 0. Here, you're going to have to decide, is it better to use your remainder theorem, or is it better to use synthetic division? I might, in example A, actually figure out what happens when I plug in x equals -1. Because mental math-wise, can you see that that's not going to be too hard to do? You're going to have -1 cubed minus 6 times -1 squared plus 5 times -1 plus 12. This will be -1 minus 6 minus 5 plus 12 equals 0. So as far as mental math goes, that actually was pretty easy. And here the remainder theorem might be quicker than synthetic division. But if I'm looking at B, C, and D, where I'm plugging in 4s and 3s, those numbers might get really big. So in B, I might decide, in this one, I'm going to try my synthetic division. 1, -6, 5, 12. Bring down the 3. And in part B, I get a remainder of 0 as well. So I've now found out that this one and this one are factors. For part C, looking at that 4, I'm thinking my synthetic division might be quickest. 1, -6, 5, 12. Wow, here we go. Sorry, guys. What's going on? Yeah. Okay, bring down the 1. That's a 1. 1 times 4 is 4. I got ahead of myself and I multiplied.
You did that.
Oh.
But it's still right, though. It still is factorable, even if you did 2 by 1.
Okay, well, you guys got to point that out quicker. Thank you. Yeah, bring down the 1.
I was doing it.
No, you bring down the 1 and it's supposed to be 1. Sorry, let's do that again. It still works out? Whew. So 3 times 1 is 3. This will be -3. This is -9. That makes -4. Makes -12. Wow. Totally lucky that it still worked out. Oh, I did some extra mental math wrong to make it work? I don't know. Here we bring down the 1. 1 times 4 is that. This is -2, -8, -3, -12, 0. This one is also a factor. And finally, part D, you'd have -4 outside, 1, -6, 5, 12. Bring down the 1. Actually, write a 1. -4, -10, +40, 45. So in synthetic division, sometimes you do end up with big numbers, as is this case. -180. And let me just check. Is 12 minus 180 0? No. 168. So the last one isn't a factor. What's really cool about the fact that we found 3 factors is with an x cubed equation, which this one is, x cubed minus 6x squared plus 5x plus 12. With an x squared equation, you can get at most 2 factors. With an x cubed equation, you can get at most 3 factors. And we found 3 factors. We found out that, which are the ones that worked? The first 3, x plus 1, x minus 3, and x minus 4. This is equal to x plus 1, x minus 3, x minus 4. And we just factored it completely. Okay? I will tell you something. You won't just keep trying factors until you get one that works. Watch. Once you found out one of them works, and what was the first one we found out that works? Well, let's say you found out x minus 3 works because you did synthetic division and got it to work. Once you found out that x minus 3 works, you would write your division statement, and you'd have x minus 3, and what were we left with? If I scroll up here, we were left with 1, negative 3, negative 4, which would be x squared minus 3x minus 4. And this you can factor with your old. Can I factor this? It would have to be x and x. How am I going to get 4 and get a negative 3? I would need negative 4 plus 1. So the questions you can do for this one are 10a and 12.